again, and I'll just give a brief introduction of myself. I've almost like 10 plus years in experience in the industry, and I've worked almost like 5 years on Amazon Web Services itself and cloud technologies. I worked in like almost 5 years in US, and I moved to I worked in Singapore, Dubai, and Qatar. Currently, like I'm working with one of the clients in Qatar with HP. So in this demo, I just want to like with my experience, I just want to give out my experience out in this Amazon Web Services to you guys. Let's start off with a small demo on Amazon Web Services. So I know, like, I assume like you have heard about the term called cloud computing. So let's see what exactly is cloud computing. Cloud computing is a model for enabling convenient and on-demand network access to a shared pool of configurable computing resources. Resources might be network, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. In a lame word, I'll tell you what exactly is cloud computing. The cloud computing providers, we have big players like Amazon Web Services, Google, IBM, Microsoft. These are all the providers of cloud computing. So they have a share, like they have a huge number of servers, networking device, servers, and storage. They have a huge hardware. So they bundle it up everything and sell it online. I mean to say they sell the resources such as server, storage, and application and services online. So cloud computing is a model for enabling convenient on-demand network. So whenever we need or whenever there is demand from the consumer side or the client side, they should be able to access from this shared resource pool of network storage and servers. And these services should be provided in a quickly. That should be provided rapidly, in a few seconds or in a few minutes. That should be available to us. And released like when we are done with the using of those resources like servers or network or storage. When we are done resourcing, when we are done using those resources, we should be able to release with minimum management effort or nothing effort, which is provided by the service provider. As I told you, there are like many service providers, but top four would be Microsoft, Amazon Web Services, and Google and IBM. So here, let's talk about some of the computing models. We have like traditional IT, where let's say like 10 years back, if you want to build a system, or if you want to host a application, or if you want to host a database, okay, what we used to do, like we used to have a meeting, then we used to discern what is the capacity planning. Capacity planning is nothing but used for deciding the hardware we require for our application or our company. So we used to do our capacity planning. Then we order the networking device, storage devices, and once we order it, the providers will ship it to your data center. We need to rack it to the data center or wherever you place it the servers, and we need to cable all the servers, and they should come up into our intranet. From there, we used to install our OS and application, and then security, and then we used to maintain the applications. So from top to bottom, we have to buy each and everything and maintain from ourselves. So we have some models in cloud computing which reduce our work. See, from on the traditional IT, you can see from top to bottom, we have to manage everything. There are other models in cloud computing called as IaaS. That's the infrastructure as a service. And we have PaaS, that's a platform as a service. And we have the last one we call it software as a service. So coming to infrastructure service, these services, they maintain all the hardware, or they buy the servers, they maintain the cabling, they maintain the networking and stuff, and they have install a hypervisor on that hardware called as virtualization. So they give us everything online, all the hardware virtualized, and then they give out the virtualized hardware that's managed by the vendor. So all we need to do is the managing of the servers. We don't need to install the OS, so we just need to maintain the servers. We need to manage the server, we need to manage the database, we need to manage security and integration, and we need to manage the applications and runtimes. So there is a lot of burden reduced. Like whenever we go on the internet and ask for a server, you will be provisioned within a few minutes. So when you sign up into Amazon Web Service, you will realize how easy is it to host a website or to access a web or access a server, a Linux server or a Red Hat server or a Windows server. It's very much easy. Within few minutes, you will have a server on your desktop. So coming to the platform as service, here the vendor manages everything. Vendor does everything except the application. So some of the good examples in platform as service would be Microsoft, C++, VB, and Oracle database. Where they give a platform on that we create everything whatever we want. There will be multiple, parallelly accessing that software many things. If I give an example like Oracle database, not only our team, other team might be accessing our database. They might creating their own tables or databases. So coming to the SaaS, that's a software as a service. Here we don't do anything. We just use the service online, which is available online. The best example would be for software service is Gmail or Yahoo Mail. That's a service provided by the vendor. We don't care about what is going backside of that application, Gmail application. We just use it whenever we want it. That's it. We are not even paying. That is a free software. That's one of the best example of software as service. There are other paid services also, software like Office 360, which is also like public, but it's also software, but you have to pay it on per year. So I'll just brief about cloud computing. Like what are we have 5 basic things while characteristics of cloud computing, which includes on-demand self-service. That means the cloud computing has the ability for an end user to sign up and receive services without the long delays that have the characteristics of traditional IT. In traditional IT, we used to wait at least 2 weeks if you want to if you want to have a website running on our end. We used to wait at least 2 weeks. Now within few minutes we'll be having a server in our desktop. So there is another cloud computing provides an ability for an end user to sign up and receive services without long delays that has characterized traditional IT. Broad network access. We should have, it provides the ability to access the service via standard platform. That is a desktop, laptop, mobile phone, whatever device you have, it will provide on a broad network access. We have resource pooling. Resources are pooled across multiple customers. As I told you, the providers have a giant of resources. So they provide you for multiple customers. We can also purchase dedicated, but that's a bit costly when we go for dedicated. That's for mostly when we have a highly secure project. And we have the rapid elasticity. Rapid elasticity compatibility can scale to cope with demand with demand peaks. If we having a sale, for suppose Amazon or Flipkart has a sale. So generally there might be 1,000 customers per day visiting the Flipkart or Amazon site. Imagine on a sale day, if the customers suddenly raise up to 1 lakh or 2 lakhs. So the server should handle the load. So in that case, when we go for cloud computing, it will elastically increase increase the server's backend as well as the loading servers. It will increase automatically and handle the load appropriately without any interference or without even knowing the customers, and decrease automatically once the peak is down. That's the rapid elasticity. Measured service. Measured service is nothing but billing is metered and delivered as a utility service. As in every house we have electricity, we have fan and light. Now they will be charging us whenever we are switching on a fan or light. They will be not charging big just because we are having a fan and light. So in the same sense, we will be charged whenever we are using the service. Just by signing up into the AWS service, we are not getting charged. They will bill as metered and delivered as a utility service. So these are some of the cloud computing stacks. As I told you, as I given you some of the examples in each of the services, we have virtual machine, server, storage, load balancer, and networking device in the infrastructure service. So some of the examples. And in the platform, coming to the platform, we have runtime execution, databases, web servers, and development tools. And that might be those are a few platform as service examples. And coming to software service, we have CRM, email, virtual desktop, communication, and games. Games you just play it online. You don't care who is hosting it and what they are doing in the background. You just play it and just close the browser. You play it on the browser. So you are using cloud clients, call it web browser, mobile app, thin client, terminal emulator. These are some of the examples of cloud clients where you utilize these services. It might be an infrastructure service, it might be a platform service, or software service. We are utilizing these services from the cloud. So let's see some of the characteristics of service as infrastructure. It's accessed on a web, so web access to commercial software, and we have software is managed from a centralized location. We don't care about the software because the software provided by the vendor completely. We are just using the software and closing out whenever we don't want. The software is managed from centralized location, and software is delivered like Gmail. They might be having one application which is delivered from one to many. They'll not be having a single application to one. Just an example. Imagine your application is there. You will be serving like one to many. So in the same sense, software as service is delivered on a one to many model. Software service like users are not required to handle software upgrade and patches. It's a clear sign. Like you go to the Gmail, you just ask. You don't care about the patches or the upgrades it's doing from their end. You will be just utilizing the service. An application program interface are allowed for integration between different pieces of software. This means API is nothing but a login screen. It might be a human to an software like Gmail. Like you are logging yourself to access your email. We have a login ID and password. But there are other APIs which communicate between each piece of software. Different software will communicate via a small API. They have some set of protocols by which they communicate, and they use application program interface between those pieces of software. Let's see some of the characteristics of platform as service. Services to deploy, test, develop, and host and maintain the application is the same. So best example would be Oracle database. This thing platform service. Oracle database are example of platform service. Okay, in that we test, we develop, we deploy, and maintain. We also have web-based interface. We also have web-based interface creation tools, modify, test, and deploy different UI scenarios. In database also, we'll be able to create, modify users and test them. And coming to the third point, we have multi-tenant architecture where multiple concurrent users utilize the same development application. As I told you before, Oracle database we have installed. Multiple people can access that Oracle database and create their own databases, their own users, their own tables. So multi-tenant architecture where is on the platform as service. You can build in scalability of developed software including load balancing and failover. There is a built-in scalability of deploying software including load balancer and failover. There are different scenarios in database or other platform service providers where they have load balancing already installed in them and the failover scenario installed in them. Like in Oracle database, we have a scenario called a standby database. That is a failover database. Like once the primary application is down, we will able to move to the failover or the standby database. Integration with web service and database via communication standards. So integration between the web service and the database is done via common standards. As I told you, there might be some application APIs in between the web access and the databases. Platform service also have examples from also has tools like CRM and stuff for project planning and communication tools. And even we have a communicator that is support for development, team collaboration, some PaaS solution included. We also have team collaboration software which works as a platform services. So finally coming to the IaaS, that is the infrastructure service. That is what Amazon Web Services provides. Most of the service provided by Amazon are infrastructure service, because they provide all the raw devices virtualized. Like after they have done the virtualization on the hardware device, they provide them as a service. So resources are distributed as service. Resources are in the sense network, servers, hardware, database, load balancing. All these are called as resources. They are distributed as service. Allows for dynamic scaling. So as I told you in the Flipkart example, the scale might be the server might go up and down, but due to the characteristics of IaaS, it allows dynamic scaling. Scaling is nothing but increasing of the increasing of the server's backend or decreasing it. Whenever the load is low on the website, so the server should come down because of the cost saving thing. And when the load is high, the server should go up and it should handle the load. Has a variable cost, utility pricing model. As I told you, it's a utility pricing model. So whenever you are using the service, then only they will be charging us. So until then, we can use their services. Generally include multiple users to users on single piece of hardware. As I told you, they have a huge pool of service resources. Resources might be servers, databases, networks. So multiple users can use a single piece of hardware. And don't worry about security. There are a lot of security given from the Amazon site itself. So multiple people use a single piece of hardware. So this is the Gartner's Magic Quadrant. They are the Gartner's people. They forecast, and they also they make a huge survey from all the companies and come out with all these figures. Like I was saying on here, this is an infrastructure service picture from the Gartner's Magic Quadrant. Here you can clearly see the leaders are Amazon Web Services and Microsoft, but Amazon Web Services are way ahead from all the other players like Google, IBM software. We have Google's Azure. Compared to all these players, Amazon Web Services are very much ahead because they started way in 2002. Microsoft, Google, and they also started in 2008. So IBM, Red Hat, and Google they are still in development phase. Whereas Amazon, they have developed a long back and they are into giving services. They are giving infrastructure completely as service. So I hope you guys understand at least virtualization. So you can just compare in virtualization we'll have cloud also is nothing but virtualization, but it's on more advanced level than virtualization. Virtualization, you need to have a box placed inside in your company. You should buy a huge number of hardware. You need to have a hypervisor installed on it. That's the virtualization software installed on the hardware. Then you need to utilize. Whereas in cloud, you don't need to maintain all those things. In virtualization, human intervention might be there for interaction with the VMs. A human interaction, a human hand should be there for interaction between the VMs. Whereas in cloud, you don't need a human interaction. It can be done via API. That's an application program interface. This all you will understand when you build a website or when you have your own application. You will be more understanding all these things. So these are some of the characteristics and the difference between the cloud and the virtualization. So cloud is self-service. So from scratch to everything you need to maintain. They will provide all the hardware, but the application development and the customization of your software that will be done from our end. Cloud also has PaaS and SaaS. That is platform as service and SaaS. And coming to the virtualization, it's automated management possible with add-ons. And licensing should be there for maintaining the virtualization. These combination nothing but the infrastructure service. That's the abstraction of hardware from the user interface. So we'll have all the hardware installed, and they'll apply a hypervisor or a virtualization layer on it, and they will give that service to us, and we pay it on demand. Whenever we utilize that service, we'll pay it. So these might be the characteristics and the difference between the cloud and virtualization. And coming to the cloud, increased stability of existing applications. So they expand and contract capacity on demand. So as I told you, as we discussed, it will expand and contract capacity. Capacity nothing but the number of servers or number of hardware devices. What it will expand as well as contract on demand. It will support parallel workloads. Multiple people can access same servers. Increase customer self service. We have they will provide you hardware, but we need to maintain all the servers. We need to configure the networking thing. Okay, and we have support dynamic workloads. So whenever there is a peak, the cloud can upload the cloud, or the Amazon people can handle the workload. Whereas coming to virtualization, we have to have a big hardware footprint in our IT premises. That's the consolidated hardware footprint. It increases service availability because it's locally present. We can have end-time access to that virtualization software. You can move your legacy application into modern hardware. Your old CPU application can be moved into modern hardware on the virtualization. Even on the cloud is possible, but you need to know a little bit more about how to move into the cloud. Once you're done with this support, you'll be able to understand what it takes for you to move or start a small website or build a website on the cloud or Amazon Web Services. So coming to here, there are different types of clouds on the internet. So there are private cloud, hybrid cloud, and public cloud. So let's talk about for a few minutes. What is public cloud? It describes a common cloud computing whereby a service provider makes resources like software and data available over the net. Software in the sense anything like infrastructure service, that might be a software. You just open an account with Amazon Web Service. You'll have all these features, all the services provided by Amazon Web Service available on the internet. In a public cloud model, the cloud services are provided a virtualized environment and constructed using pooled shared resources and are accessible over the public internet such as internet. It means whenever you sign up for an account, whenever you sign for an Amazon or Google or IBM, whatever cloud provider you are signing up, they will have a pool of resources. Resources in the sense servers, networks. They'll have a pool of servers, and they already have virtualized them, and they will give you the access to the virtualized environment. They will give you from the shared physical resources, because the physical resources are shared for multiple customers. So you can able to access over the public internet. So there is a private cloud. Private cloud allows customers the benefit of cloud computing, self-service, automation, consolidation, and metered usage, but behind the safety of their firewalls on their own private network. Private cloud is nothing but an intranet. In the company, we have intranet for communicating between our colleagues or our servers, which we have internal to our IT premises. But it also has it also has connection to the internet. The private cloud also has, if you want, also have a connection to the public network. So one of the best thing in private cloud is we can have our own virtual private network, and also we can have access to the internet via a VPN or via a firewall. So private cloud allows customers the benefit of cloud computing, self-service, automation, consolidated, and mixed usage, but behind the safety of our own firewall, maintaining on our own private network. Hybrid is nothing but combination of these two, public and private. So they use half of their server, they might be having half of the servers on our IT premises and half of the servers on the Amazon Amazon Web Services. So I'll just give a brief introduction about Amazon Web Services, because these are the Amazon Web Services are the leading guys in the industry. So let's see an introduction overview. I designed this code to pass the AWS System certification and if possible, architect associate level. Okay, and this course is designed for people ranging from server architects, server engineers, developers, Java professionals, PHP programmers, Windows and .NET professionals, and startups even. Basically, and the great thing it's very much useful for startups who want to start their own business, who want to start their own website. You will be just spending some few hundreds of rupees. That's it. Whereas if you buy if you host your website on somewhere, that will cost you very very high compared to hosting it on Amazon Web Services. So The course is designed like to pass exam, like no matter what the experience level is. And I'll show you some of the real time examples. And for this course, you like no programming experience is required. You just need to have some Linux experience, because I'll be using some command lines for this course, and we will be building high scalable website. Okay, once we are on the ending session, I will build like couple of servers. One of them is a website, and one of them is a photo video sharing website. So let's see like what exactly I'll be covering in Amazon Web Services and what does it have. Okay, I'll be covering the identity and access management. Under the identity and access management, uh, we have creation of users, group, roles, policies, and passwords. You might be understanding like users, groups, roles are nothing but it's a communication. Roles are nothing but similar to group, but it is used between communication for AWS resources, like internal communication. We'll use roles. We have policies, we have PaaS policies, and we have this S3 Glacier and CloudFront. These are storage components in the Amazon Web Services. S3 is nothing but simple storage service. Okay, we'll be seeing how to create bucket. Buckets are nothing but folders or directories where we create and upload our content into that bucket. So we will also see versioning. Versioning is nothing but having the number of copies of the same file for our future use, or for saving our own previous versions. And we'll see lifecycle management policy and archiving. Lifecycle management policy is nothing but like once we jump into the AWS, and we'll be just imagine, okay, once we jump into the AWS and we upload and we have our application and we upload some data to the S3. S3 we upload the data and we store over there. Once we upload our data to S3, and over the time like 6 months, your data will be at rest. Your versioning also, versioning files will be at rest. The latest one you will be using. What about the old data? That old data should be either deleted in order to save money, or if there is no use, what's the use of saving over there? So it's better to life cycle the data or archiving its data. We will enable the life cycle management policy of the data which is older than 90 days. That means we will push the data from the S3 to Glacier. Glacier is nothing but an archival storage, because it's cheap. Archival storage means you just you just save the data on Glacier for future use. That's an old data we push to the Glacier. So by lifecycle management policy, we push the old data, 90 days and old data to the Glacier. We have some tools. I'll show you the tools, and we'll discuss CloudFront also. And coming to the EC2 nothing but virtual instance or virtual server in the cloud, which is provided by the Amazon Web Services. There are different vendors who use the same terminology, but they have their own terminology. Like in Red Hat, OpenStack, they have called as compute. That is used. That is an alias for EC2 in Amazon Web Services. So nothing but EC2 is nothing but just imagine as a virtual instance or a virtual server hosted on the cloud. We'll be able to directly access that server. So and around EC2 there are lots of concepts. Once you know EC2, which is the backbone for Amazon Web Services, you can do a lot of things once you understand completely EC2. So in EC2 you have Elastic Block Store, where we install our file system, or where we have our OS. Like it might be Red Hat, Windows, whatever. That is Elastic Block Storage. We have ELB, that is Elastic Load Balancer. Load Balancer, I hope you understand. I'll show you while we are doing our practicals, and I'll show you in the while session. Elastic Load Balancer is nothing but to handle the load from the user end, from the end users, to handle the load, and Elastic Load Balancer will send out the load from the users to the servers. So it acts as an intermediary between the users and the servers to spread the load on the servers. So it will decide the load should go the load should go here. That will be decided by the Elastic Load Balancer. We have AMI, that is the Amazon Machine Images. So images nothing but ISOs. which are already built on the cloud. There are different IOSs built on the cloud. You can use like coming from like Red Hat 7, 6, 5 or Ubuntu 12. Whatever version you have, you can use. It's already available on the cloud. You have Microsoft Windows like R2, Windows 2012. We have all those IOSs like AMI. They are called as Amazon Machine Images, already pre-built on the cloud. You just need to mount on that IOS and use that. We have the auto scaling, which is one of the best concepts in Amazon Web Services. No other vendor has been able to provide this auto scaling. Auto scaling is nothing but it's an web interface to, I can say, will write some small like notification. Like if the server CPU is 80%, add one more server. I mean, according to the load, if the server CPU is 80%, will automatically add an EC2, add an extra server to that application. Or if the CPU is if the CPU utilization is less than 50%, so reduce the EC2, reduce the virtual instance from their application. So the human interaction, like once you write the script perfectly, human interaction will be almost nil. You don't really have to wake up in the night and add one more server to the application, or see why the load balancing is failing. You just know why the load is failing. Once your auto scaling is done perfectly, you just relax. Whether you have 100 users accessing your website, or 1,000 or 10,000 or 1 lakh, doesn't matter. It will handle the load. Auto scaling will handle the load. There are instance we have instance types, because a virtual instance can be we have many types in virtual instance. We can have a general purpose. We can have like where there is more memory in the server. We can also have where there are more CPUs. And coming like if you are going for a database server, we'll be having more IOPS. IOPS like input output per second. So the communication between that server should be high. So we'll go for high IOPS servers when coming to the database servers. Those are like instance types. And we'll also discuss about the security while dealing with EC2s. EC2 in the sense virtual instances. We'll see Route 53. That is a DNS service from the Amazon. 53 is the DNS port, so that's why they have named Route 53. We'll see how to host our domain, how to host our website on the AWS using S3 and Route 53. You just no need of EC2 instance, or no need of a virtual machine. So you just upload your data on the S3, and you can directly add that to Route 53 to host a website. I'll show you how to host a simple static website once we are dealing with the like AWS service. Like once we go into deep practical, I'll show you all these things, and we'll do some health checks on all the services, AWS services. And coming to the database, we have different databases in AWS. So we have RDS, SQL, DynamoDB, NoSQL, and Aurora. We have other types also like MySQL. We have Microsoft SQL Server. We'll be discussing on all the things. Okay, once we jump into the like detailed services. Coming to the VPC, that is a virtual private cloud. So here we'll be designing private, public, custom private cloud, and address, and we'll be discussing about address network translation. That is a NAT device. We will be developing a NAT device. So NAT device in the sense like in our home. Okay, we have a Wi-Fi router. That's a NAT device. We'll having four. Just imagine we'll having 2 laptops, 4 phones. But how does one router? It will have a small table of our MAC address and IP address. But we'll have only one public connection. So while going through it, it will note down our IP address and our MAC address, and read out the public internet to our IP address. We'll discuss about ACL, that is the access control list, and come into the various application services provided by Amazon. We will discuss about ES, that is the simple email service. We'll discuss about SQS, simple queue service, and we'll discuss about SNS, that is not SNS, that is SNS, that is a simple notification service. And we'll also deal with elastic beanstalk and cloud formation. Cloud formation in the sense like uh, so I don't know how much guys you have like, exposed to the outside world. Like in a company, we'll be having different environments. We'll be having a production environment. We'll be having a development. We'll be having QA. We'll be having a like other UAT and stuff. Like if you like once the QA is done, and if you once you QA like once you configure the EC2 server, once you configure the route to P3 and other application, that's a QA service, QA environment. We can make that complete QA service as a template and get it as a cloud formation. Okay, cloud formation nothing but a template of your AWS stack. Stack in the sense it includes EC2, VPC, virtual machines, database and everything. That's a stack from that's a stack. So cloud formation is a template of this like AWS stack. So from that template, you can deploy n number of QA, n number of development, n number of protection. So you don't have to create each servers. You don't have to create VPCs and nothing like that. Once you have a template in your hand, you can create completely environment in a few minutes. Complete environment. Either it might be QA development and whatever it is. You can just quickly deploy different environment in a few minutes. At the end of the course, we will be discussing like how to build a simple WordPress application in the cloud, okay, website, and coming to the last one, and we'll be building a community-based photo video sharing site. Small application I will be sharing with you guys, where we can build a photo video sharing website. So what exactly you need to do here? You just go into the Amazon Web Services. Okay, there is a free tier 12 months. So once you go into the Amazon website, you'll understand there is a 12 months of free. I mean, we can use the Amazon Web Service 12 months of no charge. That's a free tier. It's for 12 months. Utilize it and learn it as much as possible. And for some of the command line interface, you need to have a SS kernel, and we can have a domain name. That's an optional one. I'll show you why you need, like if you want to host a website, you need to have a domain name. In this certifications, so like these are certifications available on the Amazon Web Services portal. I am certified in solution architect and SysOps. So I'll be like my session will be covering on these two, most of them. So like, and if you think on a professional level, it's good to have the certification, because in the market or the company will be looking for certification. So just take care. I mean, just make sure that you get your certification, because it's very much an added advantage on your resume. If your experience or not, that doesn't matter. But if you have your certification, that will be definitely an added advantage on your resume. On for yourself even. So my session will be covering these two most of the concepts, and I will be giving you hints and some of the quiz sections. Like while we are doing this session, so which will be helpful for both this certification. So these are all the deployed Amazon platform. We have various components under AWS global infrastructure. We have networking, we have compute, we have storage, database, analytics and application service, and we have like different deployment and management tools. So this is the interface of the Amazon Web Services. So as I told you, we will be dealing with basic services such as you can see as EC2. EC2 will be talking a lot. A lot means a lot. We'll be talking about EC2. We'll be discussing spending a time on S3. That's the storage component from AWS, and we'll be seeing Glacier, CloudFront. CloudFront nothing but a global content delivery. Okay? It delivers our data to other parts of the world within few seconds. So we'll be talking about CloudFront, and we will be seeing all the database servers, especially the RDS and DynamoDB. And coming to the network, we'll be seeing the VPC and Route 53. VPC is a virtual private cloud, where we have our own dedicated cloud connected to the internet. And Route 50, as I told you, it's a DNS provider from the Amazon. So I'll be discussing mostly on route switching and VPC in this time. And coming to the administrative security, I'll be mostly telling and dealing with identity and access management. That's where you create a users groups and roles for your company when you're working with a company. And I'll be talking about CloudWatch. CloudWatch is a service that monitors all the other AWS resources. It's a watchdog, I can say. So CloudWatch. So everything it will monitor every other resource in the Amazon Web Services. I'll be talking about Elastic Beanstalk, and I'll be talking about Cloud Formation in the development and management. And analytics, these are way ahead, very complicated, and that's what future mostly for advanced guys. And coming to the application, I'll be talking about SQS, that's a simple queue service on the Amazon, and I'll be talking about SES, that's the email service from the Amazon. And one more thing from the mobile service, I'll be talking about SNS, that's the simple notification service from the Amazon. So that's the demo class. If you attend or not attend, I don't care. But I'm just saying because just sign in. Just make sure you sign in on the AWS platform, which is for 12 months free. Okay, just sign in on this website to utilize the services for 12 months, and make sure you just spend time on this one so that you will understand you understand each of the components in the cloud, which is provided by Amazon Web Services. So if you have any this cloud, just let me know now.